Hello everyone, welcome to Pipesim Python Toolkit for Beginners. In this video, I'll show you how to work with boundary conditions for network simulation task and how to set up network constraints. Let's start from the simple code. For this video, I use the model CSN301 small network, which is located in Case Studies Network Models. I opened this model in my session and saved it in the temporary folder. In the user interface, we can see that this model contains one source, one well, and two sinks. We can check the studies and see that there is only one study. So we don't need to use the study name when we run simulation in PTK. In the network simulation, we can check the boundary conditions. The pressure is defined for well and for both sinks. For source, there is a gas flow rate, and the temperature is defined for well and source. On the rate constraints, we can see there are no constraints. So this model is configured to be run without any constraints. So what I'm going to do in my exercise is to replace the pressure boundary condition for the well and use instead the flow rate, liquid flow rate. But before I do it, let me just run the simulation and check what is the current liquid flow rate from the well. We can see on the node branch results tab in the well row, we can find the flow rate is 5060. So I'm going to use this value, change it slightly, to update the boundary conditions. Let's go back to the code. So in my code, before I update anything, I need to know what's the current boundary condition. So let me extract this information from the model. I will use model, task, then select the task from the list, and I will use method getConditions to extract the data. This method uses two arguments, useSurfaceConditions by default as value bool, and the study. Since we haven't changed anything, so we use just default configuration, so I just keep these brackets empty and extract the information. We can see that the output is a dictionary where the first key is the name of the component, well, vertical completion, or the source. And the value of this dictionary is another one dictionary with properties. There are a lot of properties here, but I need to focus on the value that we saw in the user interface. So we saw the temperature was defined, pressure, and then the flow rate was the liquid flow rate, and the value of the liquid flow rate was empty, so the none was used. I'm going to copy this structure to create the new boundary conditions. There are two ways to define the boundary conditions. First, of course, we can save this output as a variable, then update the properties what we need. And the second is defined from scratch. You need to remember that every time when you update conditions, Pipesim takes new data for each component what you mentioned in your data and search the same component in the model. And if you use the same data, you just spend time for comparison. So I recommend adding into the dictionary the new data only to avoid code performance issue. So let me create the new variable. I will call it boundaries. And it will be the dictionary. I need to copy the name of the object I'm going to update. It will be well, vertical completion. And the value will be another one, dictionary. And I need to type the properties, parameters, boundary, and let me just copy because it will be used later. And first I want to remove the pressure. For this purpose I will pass none. Second, I need to set up the temperature, and temperature will be 150. Now I need to make sure that the flow rate type is liquid, so I will type flow rate type and use constants class flow rate type and select from the list liquid flow rate. And now I need to set liquid flow rate and pass the value. You remember that currently the well produce 5000, so I'm going to use 3000 just to make sure that the values are not the same. So I define the new variable and I need to pass it to the model, update the model. There are ways to update the model. The first way is to explicitly set new conditions, and the second way is to pass this variable as argument when you call run method. I'm going to use the first way. I will type the model tasks, network simulation, and then set conditions. Here you can see that you have several arguments: boundaries, constraints, surface conditions, and study. Since I'm going to just update only the boundaries, so I can type the boundaries and the name of my variable, boundaries, and update. So the model was updated, and now I can save the model and check my changes in the user interface. So let me just open the same model in user interface, then open network simulation type and see. You can see that the pressure is not defined anymore for the well, but instead of the pressure, the flow rate is used, and the value, as we expected, 3000. So if we run the simulation user interface, Pipesim will calculate the pressure for the well. So the calculated pressure is 632. I expect something similar in my PTK code. But before we run the simulation, I want to simplify the output to speed up the simulation. I don't need to use profile variable, so I will pass empty list as a profile variable, but for system variable, I will request several variables. I will use system variables and then request volume, flow rate, liquid stock tank. Then the second variable will be system variables, and here I need to have the pressure because the pressure is calculated, and I also want to get bin size. It will be used later. So the variables are defined, and now I can run the simulation. I will save it in the results, then call model, tasks, network simulation, run, and use profile variables empty list, and for system variables I will pass system variables list and run the simulation. Since my list of variables is short, so I don't expect long simulation. Yeah, we have the results. And now we need to get access to the output. So I will use nodes, results, node, and see what we have. The output contains dictionary with name of the property, and then there is value, then another one dictionary with name of the object and values. So we can see that the flow rate for my well, vertical completion or well in general, is 3000, and this value was defined as a boundary condition. But the pressure was calculated, and for the well we have the value 632. This value was calculated and we saw it in the user interface. Okay, so I've done it successfully, and the next what I wanted to do is to remove source from the simulation in general. So for this purpose I need to redefine boundaries, and this time I'm going to use source, and as argument I'm going to use isActive method with false value. So the boundaries were defined. I need to update, so I just copy set conditions and update boundaries, and now I'm ready to run the simulation. Let me just copy the same line and I will run it one more time. So the simulation is ready, and we can request results node. Let me type it, results node, and we can check if the source is available in the output. We see no source here. It happens because the source was excluded. Let me save the model and make sure in the user interface that the source really is excluded from the task. I'm just going to open the model one more time, open network simulation, and you can see that the source is not active anymore. It was excluded from the simulation. But what if I'm going to reset everything? So I'm going to reset boundary conditions and revert to original model. I can do it using the following method: model, tasks, network simulation, and then reset conditions. And all conditions will be reset to the original one. So the values from the network will be used to redefine the boundary conditions. Now we can play with constraints. What if I want to know what the current constraints are? So I can use the model, tasks, network simulation, and then I type get constraints. So we can see that we have a study here. I can skip it because there is only one study. and this output I've got the empty dictionary. It happens because there are no constraints in my model. So let me define the constraints. I will create the new variable called constraints, and it will be a dictionary. As you can guess, the first key should be the name of the object. I want to apply the constraints for the well, and I want to limit the liquid flow rate. And if you remember the first run, we've got the value is 5,000. So I'm going to set the limit for liquid flow rate 4,000, maybe 500. So I will pass another one dictionary, type parameters, then rate constraint, and select the liquid flow rate and define the constraint 4,500. So it's a new constraints for my model, and I need to apply them. Again, I can do it using two ways, but I'm going to do it explicitly. I will type the model, tasks, network simulation, set constraints, and say constraints, and define my constraints. And now I save the model. I want to check it from the user interface. Let me just reopen my model one more time. Go to network simulation, check rate constraints, and now you can see for the well there is a maximum liquid rate. And since the well has this choke, so these constraints will be used to recalculate the choke diameter. Right now we have the bin size is 2 inches. So we can check what's the calculated bin size. Let me rerun the model one more time and see what's the calculated value. So I will use the same structure. Just want to show you that the previous time when we calculated the bin size was 1.9999, and now I'm going to recalculate everything with constraints. And if we type results node, we should see that the choke diameter was changed. Now it's 1.5. And the same value you can find here if you run the user interface. You wait a little bit to get the results. Then go to the node and expand choke. And you can see that the bin size is 1.5. This is calculated bin size to meet your rate constraints. And remember that you need to close the session at the end of your script. So let's do it. Model, close, and now we are done.